Okay, so we are back to 3D now, and I'm just gonna represent a 3D space as best as I can. There you go. Z-axis, X-axis, Y-axis, and then I'm gonna present two lines. Now, it's very hard to represent to visualize that because because we are just trying to represent a 3D space on a 2D surface. Okay, that's 1, 2 line. Right. So there are three possibilities for this line. They could be parallel. First possibility. Or they could be perpendicular. They could intersect or not. Now, if they don't intersect, but are not perpendicular, but are not parallel, sorry. They actually parallel or perpendicular. Yeah, perpendicular. They are said to be skew. Let's do an example. So we have two straight lines, and the okay, the parametric equation of these lines are for line 1, x1 is equal to minus 2 plus 2t, y1 is equal to 1 plus t, and z1 is equal to 4 minus 2t. That's the parametric equation of line 1, and for line 2, x2 is equal to 1 plus 2t, y2 is equal to 3, actually I'm going to change the parameter and give it another name, plus 2s, 3 plus 2s, and then z2, which is 2 minus 2s. And the question is, intersect? Are they parallel? And are they perpendicular? Right. Probably better by starting by question 2, actually. So, are they parallel? Well, here, for the first one, the vector component of line 1, which I'm going to call u, is what? Is 2, 1, minus 2, which are these coefficients here. Whereas for line 2, u2, the components are 2, 2, minus 1, minus 2. Well, it's pretty obvious that there does not exist lambda such that u1 is equal to lambda u2. Because here, to go from 2 to 2, there is a factor 1. To go from 1 to 2, there is a factor 2. And to go to minus 2 to minus 2, there is a factor 1. So therefore, they are not parallel. Okay, that's established. Now let's do perpendicular. Are they perpendicular? Well, if they were perpendicular, we would have u1 dot u2 is equal to 0. Well, let's test that. u1 dot u2 is equal to 2 times 2 plus 1 times 2 minus 2 times 2. Okay, so it's 0, 0, so it's equal to 2, so it's different of 0, so they are not perpendicular. Now, 1, do they intersect? Well, okay, so for them to intersect, we must have at the same time minus 2 plus 2t is equal to 1 plus 2s. 1 plus t is equal to 3 plus 2s. And then 4 minus 2t is equal to 2 minus 2s. Now, this is equivalent to, so what do we get here? Let's move all of the components, so that means that 2t is equal to 2s plus 3. Okay, so that means also we can get t here is equal to 2s plus 2. Yeah, maybe I should have started from this one. And okay, so let's, I'm not going to write the third one. Let's start from that. If I substitute this into this equation, so if I, so if, so okay, let's try to find a value. So okay, let's substitute that into this equation. So we get 2 times 2s plus 2 is equal to 2s plus 3. That means that 4s plus 4 equal 2s plus 3. That means that 2s is equal to minus 1. So s is equal to minus 1/2. If I substitute that, so and then and so if s equal minus 1/2, that means that t is equal to 2 times minus 1/2 plus 2, which is minus 1, 1. Okay, let's see if that works with the third equation. So 4 minus 2 times 1, that's equal to 2, whereas 2 minus 2s is equal to 2 minus 2 times minus 1/2, which is equal to 2, 3. Okay, so this doesn't work. So therefore, they are not. So there is not such a thing, such a parameter t and s, such as x, y, and z, have the same value at the same time. So therefore, they don't intersect. So they are skew. That's it.